All right, in this lecture, we're going to be talking about weathering and soils. Okay, so what's weathering? Weathering is the dissemination, destruction, or breaking of a rock to finer particles. And there's two different types of weathering. First is physical or mechanical weathering, and second is chemical weathering. So an example of this is that if you have a clogged drain, a plumber can use a tool called a snake, and that's to physically unclog a drain. Or you can use a chemical product like Drano to break apart the clog that's in the drain. So those are both methods that can break apart the clog in the drain. And the first is an example of physical, and the second would be chemical. So how is weathering different than erosion? So erosion is the process by which soil and rock particles are worn away and moved somewhere else by either gravity or some transport agent like wind or water. And the transport refers to the process by which the sediment is moved. So, for example, if pebbles roll along a riverbed or seashore, or sand grains are whipped up from the wind, or salt is carried in solution. So these are different types of transport. And so weathering is different than erosion because erosion involves the removal of solid material by a transport agent. And weathering is just the breakdown of rocks into fragments, and there's no movement involved in weathering. So let's talk a little bit more about the difference between physical and chemical weathering. Physical weathering, again, is the process in which rocks are broken apart. And you can have an intact rock that either gets disconnected from the grains or has a chunk off of the large clasts, chunks known as clasts, that's a typo there. So if you think about what sort of processes this would be like in the real world, what do you think would cause some physical weathering? So usually your mind thinks immediately to erosional properties, like how a river would carry sediment or something like that. But when we talk about physical weathering, it's a little bit different. Some of these may not be as instinctive to you. So here's some examples of physical weathering. We're going to go over each one at a time. So jointing, frost wedging, salt wedging, root wedging, thermal expansion, and animals. Okay, first, jointing. So a joint is a natural crack in the rock, and the formation of a joint separates one piece of rock into separate pieces. And so when weathering occurs, the joint could break and could expose like a whole cliffside or even just one face of a rock. And they can tumble down slope and they become fragmented into pieces. And so this would be an example of joint weathering. So here in the picture on the right, you can see how there's some natural jointing in or cracks in this rock. And as pressure pushes downward, like overburden of sediment on top of it, it tends to break apart at those natural fractures. Okay, next is frost wedging. So this is where you have those other cracks like we talked about before, but then water can get trapped in between those joints. And then as it freezes, it causes that joint to continually to separate. So, when you're making ice in your freezer, if you've ever frozen a water bottle before, you know that you have to like pour a little bit of the water out first because it expands as it freezes. And that's what happens here is that water is inside those cracks, and as it freezes, it expands and causes the crack to grow. Salt wedging. So in arid climates, dissolved salt in groundwater precipitates into pore spaces in rocks. And these form rock crystals that push apart the surrounding grains of the rock. And salt wedging weakens the rock so that when it's exposed to wind and rain, the rock then disintegrates into separate grains. So here's an example of salt wedging that's destroying a tombstone. We don't see this too often here, but we definitely do see some root wedging. And this is where roots from a bush or a tree pushes joints open. So have you ever seen the roots break apart in a sidewalk? I think that's fairly common here, where you see like not just grass, but like a nearby bush has rooted underneath concrete slabs and pushes its way through a crack in a slab. That would be an example of root wedging. So here in this picture, you can see that a tree was actually growing in this joint. You can see how this rock is totally separated now because this root has wedged the rocks apart. And over time, if enough of this wedging occurs, you can have large rubble that comes off of the rock face. Okay, next is thermal expansion. So intense heat from something like a forest fire or direct sunlight causes the outer layer of the rock to expand. And then when it cools, it contracts again. And that forces the rock to break off of the main rock unit. So in places like in the desert where it has extreme temperature variations, over time it causes these fractures to break and they can break into thin slices. So again, if you have, places that are like, think about the Arizona desert, where the high temperature could be 100 degrees and the low temperature, during summer could dip down into the 60s. That's a huge temperature variation. And if you have sediment that is sensitive to changes in temperature, that's what would cause a lot of thermal expansion. And last, animals can create they can burrow into the earth like gophers, or on the smaller scale like earthworms. And also we might be considered animals. So humans have a huge impact on weathering because we excavate quarries for digging. We shatter and displace large volumes of rock that would otherwise remain intact for millions of years. If we do a lot of mining, take away huge rock faces for our roads that we build through, we're part of a physical weathering process. Okay, so contrasting to that is chemical weathering. So chemical reactions that alter or destroy minerals when rock comes in contact with either water solutions or air. And so when you think about this, what would be a chemical process that might affect rocks? Something that you might think of, we see a little bit of that being close to the coast. So here are some examples of chemical weathering. So the one that you might be most familiar with is rust. That's the one I was referring to just then. And that would be an example of oxidation, which transforms iron-bearing minerals into a rusty brown mixture of iron oxide and iron hydroxide. And this is where we see, rust on our cars and things like that. This is the same type of principle that would apply to soils and rocks. Another would be hydrolysis. And this is where water chemically reacts with the mineral and breaks down to form other minerals. An example of this is we have the mineral feldspar, and that gets there's a chemical reaction, and then it turns into clay. Another example is hydration, where absorption of water into the crystal structure of minerals causes some minerals to swell, and the expansion weakens the rock. So you might see this in places where we have swelling clays, and this is where you have a lot of homes that have basements or foundations that crack. Sometimes part of that is because you have swelling clays, and that makes infrastructure unstable. So an example here on the right is dissolution, and you can see how water has, there's been a reaction here of hydrolysis of water that chemically reacts with the minerals and breaks them down. So here's a table of some typical weathering effects on common minerals. So like I just said, hydrolysis affects feldspar, and the byproduct is that clay minerals plus potassium, sodium, and calcium are in solution. So some of these other ones, again, these are just weathering products of common minerals. So we have calcite is a calcium and carbonate in solution. That would be a chemical weathering. Okay, so now I'm going to show you a demo that demonstrates the difference between chemical and physical weathering.
In this demonstration, we're going to illustrate the difference between physical weathering and chemical weathering. Physical weathering. Chemical weathering. You can see it fizzing a little bit there. And lastly, combination. We're going to take the broken up pieces from before. We're going to put it in here. Now you can really see it bubbling. Okay, so that's an example of the difference between physical weathering and chemical weathering.
Okay, welcome back. So sometimes we talk about rocks, minerals, different types of rocks, but where do soils come in? So soils are typically what we refer to as the top, I don't know, 50 feet or so, maybe 100, first few 100 feet of the ground. And soils are formed by a few different things. First is the zone of leaching. This is closer to the ground surface where the water extracts and absorbs ions and picks up clays and then carries the material further downward. This can be a zone of accumulation where we have new mineral crystals that precipitate out of the percolating water. And because of the rate of water movement slows, the water leaves behind its load of fine clay. And next on the surface, we have detritus interacts with organisms, such as like dead leaves and roots, and animals constitute organic material, which mixes into the inorganic minerals of the detritus. So these are some of the things that we use to describe how soils are formed. Again, those are typically the first, tens to maybe hundreds of feet of the surface of the earth. And as soils get added on, and these clay minerals and other pieces of minerals, clays, all these things, they get deposited on the surface. And then over time, there's more overburden that pushes it down and down and down. And eventually soils do turn into rocks. So here's an example of that. Here's so we have a diagram here of the different zones of soils. And over on the far right, we have where we'd be walking here at the top on the grass. Then we have like topsoil, which is pretty loose. Like if you were to ever make a garden or dig for a tree or something, you would be hitting mostly topsoil. And this is usually pretty easy to get through with just a shovel. And then further down you go, you transition into what we call a subsoil zone. And then of course, deeper than that, it gets a little bit harder to use with a shovel, or it gets pretty deep. And so in these different zones is where we first encounter, in this context, we're calling bedrock, which would be maybe the first layer of, cemented rock or a definable rock, as opposed to all these loose soils and clays and things like that. So here, again, this is how soils are created through the total system with interacting with the groundwater, interacting with water that is percolating down from the surface. It interacts with the microbes of tree roots and clays. And then, of course, further down is where we have this accumulation of clays and ions. So there's a lot of diversity in soils, and this exists because of the different character of soil. This depends on a few things, like the climate. Is it really hot or is it really cold? The substrate composition. Like I said, the example before was a lot of ions and clays. But soils can also have different character based on how steep the slope is and where those soils can accumulate. So if you have a steep slope, you have, of course, thinner soil here and thicker soil further down. The amount of water that is added to the system, so the wetness. And of course, over time, these soils would either accumulate more ions and clays, and of course, the local ecosystem and how it might interact with different types of trees or different soils or different root systems. All of these things can change the soil characteristics. Okay, so we talked a little bit about soils and weathering. So we're not going to cover too much about soil because as geologists, we really just care about the rocks. So the things that we did talk about today is that sediment consists of loose fragments derived from pre-existing rock that have undergone weathering, and that there's two different types of weathering. We have physical and chemical. And we also talked about how the character of soil depends on the composition of its source material, as well as climate and time. So now at the end of this video, I'm going to turn you over to a YouTube video so that you can look at some really cool weathering and erosion over time on a beach. And again, this is one of those videos that if you get into a rabbit hole on YouTube, you'll find some really cool stuff.